Hello everyone, let's solve this question together. Now look at what you are given. We're going that s to the power of s is equal to what? 60 what? 4. We are asked to look for the value of x. Now before you can solve this question, we will have to recall two identities, okay, which is very important, or two fundamental what function, which is very what vital and what important. Now question like this is very simple. If you know this one, if you know the W function of what into a multiplied by e to a is equals to what? A. This is what Lambert W function. And two, we have to know one of the properties of what? Logarithm. That e to the power of what link a is equals to what? A. Now we have to take note of this because we are going to apply this in this question. Now our question is what? Is x to the power of s equals to what? 60 what? 4. Now, how are we going to know the value of x given in this given equation? Our first step, what you're going to do is to take the natural logarithm of both sides. So we'll take what? Ln s to the power of s equals to what? Ln 60 what? 4. Okay? Now, let me draw your mind to one of the properties of logarithm. That if you have the logarithm of m to the power of p base a, this law states that the power can also go back to multiply the log. So this will be equals to p multiplied by log, okay, m base what? Base a. This is one of the properties of what? Logarithm. So we are going to apply it here. So this power which you are seeing here, which is x, can also go back to become what? S multiplied by what? Ln x equals to what? Ln what? Ln 60 what? 4. Do you know that 64 is a perfect square, right? We can also express 64 in what? In exponential form. So do you know that 2 to the power of 6 is what? 64, because 2 multiplied 7 to 6 places is 64. So now what this is s multiplied by ln what? Ln s is equals to ln 2 to the power of what? 6. 2 to the power of 6 is 64 because 2 times 2 times 2 times 2 into 6 places is 60 what? 4. Now at this point, let us obey these properties. These two can also go back here to multiply the ln. So what this is what? Ln s multiplied by ln x is equals to what? 6 ln what? Ln 2. Wow, this is amazing. Now if you are trying to compare, we are not having, because s must be the same. So look at s here, is s here, look at s here, and here is 6. S here and here is 2. So there's no way we can compare this. But what are we going to do? Because at this point, there's nothing you can do anymore. That is why I put this down, these two functions. Okay, so first function, let's apply this first. Okay, in place of this x, we can rewrite this x as e to the power of what? Ln x, to represent what? X. Since by the properties of this function said that e to the power of ln a is equals to a, it means that here I can also write as what? E to the power of what? Ln what? Ln x. Now e to the power of ln x simply means what? Simply means what? X. By obeying these properties, okay, of logarithm. Then multiply by what? Ln what? Ln s is equals to 6 ln what? Ln 2. Wow, this is amazing. Can you see how simple and interesting it is? At this point, we are going to obey the second what? Fundamental what? Function. The W function of a multiplied by a, the W function of a multiplied by e to a is equals to a. So we want to take the Lambert W function of both sides, that into ln s multiplied by e to the power of what? Ln s, okay, is equals to the Lambert W function of into 6 ln what? Ln 2. Don't forget that we are taking the Lambert W function of both sides, right? Now, since the W function of a multiplied by e to a is equals to a, so this will just give us what? Ln s, because ln s stand in place of a in this what? Equation. So I have to have what? Ln what? Ln s is equals to the Lambert W function of into 6 ln what? Ln 2. Wow. Oh, this is amazing. Beautiful, right? Now we can raise this, or we know that this is in base e, so e to the power of this will give us x, right? But we can raise this to the base what? E to the power of ln x, okay, then equals to e to the power of the W function of into 6 ln what? Ln 2, right? Now please take that this you're seeing the same thing as this, because the base here is E and the base here is E. If you ignore the bases and equal the powers, you're going to what is here, right? Now, if you go back to obey this law says that e to the power of link A is equals to A. So e to the power of link S will just give us X, as you can see, right? Will give us X. X equals to e to the power what? The derivative function of into 6 link what? Link 2, right? This is the beautiful solution to this problem. Take note that it's not all calculators that have this operation, okay? And again, you can also write this as S is equals to e to the power what? The derivative function of what? Into link what? Link 64. It's the same thing. Now, before we can know the value of S, we must know the derivative function of this. If we can know the derivative function of this, that means e to the power of that value we have will give us the value of X, right? I know the value of S will be around 3 point something, okay? But you know, it's not all calculators that can do this. So what I will do, I will make sure I draw the answer on the screen. As you can see here, this is the value of X. Remember I said earlier that it's not all calculators that have this operation, right? So S is equals to what? E to the power of what? Link what? 64, or S is equals to e to the power of what? Into 6 multiplied by link what? 2. And this is the beautiful solution to this particular problem. I know you'll be wondering, what is this derivative function you're talking about? Take note that the derivative function, as you're hearing, is the product of what? Logarithm, right? Now, if you're talking about the Lambda derivative function, and what if you given a function of f of x equals to s multiplied by e to x. Now, if you're asked to find the inverse function of that function, the inverse function of x, then you know what is come about what? The Lambda derivative what? Function. You can also go to this channel and watch about the definition of what? Lambda what? Derivative what? Function. Thank you so much for watching. Please, if you find it interesting, don't hesitate. Do well to like, comment, and share the video to your loved ones so others will learn from it. Please, if you're not subscribed, feel free, okay, to subscribe to this channel so that anytime we load exciting videos, you'll notify. Thank you so much, and God bless you. If you have any question, you also drop in the comment section and I'll respond to you.